is Vojta, and I'll be talking about security issues with your third-party dependencies. First of all, are you familiar with tools like dependency managers like maybe NPM or Maven or NuGet, something like that? Yeah. Alright. So, first of all, do you know Doom?
Yes.
Have you played Doom? So basically, these days it's kind of crazy that even like a simple web page is usually as big as the original Doom, right? That's kind of crazy. It's a lot of code in even like simple pages. That means like a lot of libraries, a lot of frameworks, even for the simple stuff, right? Like how can like simple web page be as complex as like a computer game? So we have a lot of code in our applications, but the code we are using, or the code which is making your application, your own code is usually like a really small part of that. It's kind of, if you imagine like iceberg, like 10% is above the water and the rest is like under the water, right? So your own code which you write is kind of the top of the iceberg, and the rest is kind of some third-party dependencies, some frameworks, libraries, lot of stuff, right? You usually don't like write plain code without using any frameworks or libraries these days. Does anybody of you use just plain JavaScript or Java or whatever? Yeah. Okay. Yeah. Do you know NPM? Are you familiar with it? So NPM is kind of maybe the most notorious like dependency manager with really big number of dependencies. There is basically a dependency of everything, right? Who was there the last time? There was some dependency for generating daddy jokes, I think. So there's dependency for everything. So you can see that number of libraries in NPM is like 1.2 million right now, and it's growing all the time. So it's like really huge number of dependencies. And if you look at the number of downloads, it's like 63 billion downloads just for the last month. That's crazy. That's like how much we rely on third-party code, right? To kind of demonstrate. Am I not in the picture?
Yeah.
Okay. To kind of demonstrate how crazy dependencies there are in NPM, and like that there is dependency for everything. For example, it's not really visible, but here's a package which is called like isOdd, which kind of checks whether a number is like odd or even, right? So how many lines of code do you think like is to make this package?
Wow.
Wow.
120.
42.
42? Okay, so it's basically pretty much this, right? It's like 2 lines of code and you have a library for that.
So, sorry, I thought in Java.
Or in Java is maybe right. Yeah, you might be right. So, and you can even see that this library has actually one other dependency. So, something which is supposed to check whether a number is odd has already some dependency. And you can see that, 2.5 million downloads of this library each month, and 73 million downloads total. That's kind of crazy, right? What's even crazier, it's a library which is called isEven. Do you think, can you guess what it does? And how many lines of code?
Is it in one line?
One line?
Not isOdd.
First package negative.
Return is not odd, right? So this has dependency on this, and this has also some dependency on its own. So you want to check whether a number is odd or even, and you already have like, 3 dependencies? That's how much we rely on third-party dependencies these days. Alright, just another guessing exercise. Do you work with Angular? Does anybody know Angular? So let's imagine I do like npm install, right, which kind of downloads all the dependencies of my project. And it's like fresh project generated, like not even hello world. It's just like I use the generator of new project. There is completely nothing. All the dependencies are downloaded here to Node modules. How big is that? Any guesses? Wild guesses, please.
I don't know, 50 megabytes.
50. Okay.
120 megabytes.
Okay.
300.
300. That's kind of wild guess. It's kind
Some
of
kind
pessimistic.
that's specific, huh?
And how many files?
1000, I don't know.
Okay. So you are all kind of optimistic. 55,000 files, 337 megabytes. Like, to be clear, not everything kind of ends in the final application code, right? There's also like build tools and like SAS converting to CSS and stuff like that. But this is like crazy amount of third-party dependencies just in a plain project without anything, right? And we'll be talking about security a bit later, but imagine how many files, how many dependencies, how many lines of codes are they here, and what is the probability that there is some really big security issue in one of them? That is pretty likely that there is something like a security hole in such number of files and code, right? Cool. So if you know like npm or maven or whatever, you kind of know that you declare some dependencies in your file, right, in package.json or pom.xml or something like that. But those dependencies are your direct dependencies. That's something that you actually declare that you are depending on. But those dependencies have some dependencies on their own. And those dependencies have also some other dependencies. Like we saw even with like this is odd and is even, that there is like chain of 3 dependencies. And with like real application, it can look something like that. If it's a small Hello World application. If it's something more complicated, it's gonna be like, imagine all the boxes are kind of dependencies and the lines are dependencies between dependencies. So again, the iceberg analogy, like this is your direct dependencies and this is your indirect dependencies. Except this is maybe like 10 times as big than on the picture. So again, we'll be talking about security, and imagine how many dependencies are actually in your application, because you kind of think that it's only those dependencies which you directly declare, but it's a lot more, way more. Okay, do you know this story? Like a few years ago, have you heard about LeftPad? Kind of scandal, or yeah? How many of you know?
Yes, I know.
Yeah.
Cool. So basically, a long story short, there's some small library which kind of does manipulate strings in a way that you can put some spaces on the left to the string, and apparently like half of the internet was depending in one way or another on this small package, which is like few lines, 11 lines of code, I think, or something. Yeah. And the author of the library decided to remove it from npm, and everything like went down. Like half of the internet was not working anymore because there was missing dependency. So that's how much these days like the dependencies are interconnected between each other. So they even like the author of the npm needed to manually put it there, even if the author of this library didn't agree, because otherwise nothing would be working. So if you're not familiar with it, I recommend to look it up, because it's really interesting for you. Okay, more questions. How many of you know OWASP? Cool, cool. So basically, if you're familiar with OWASP, it's like a company which kind of focuses on web application security. And they have like many projects, and one of the projects is like OWASP Top 10, which is kind of a list of security vulnerabilities in web applications. Are you familiar with some of those? Maybe injection, like SQL injection, right? Like dropping all the database, stuff like that.
1 equals 1. 1 equals 1. And after
Yeah, exactly. So there are some like really nasty security vulnerabilities, but if you check like number 9, it's actually like using components with known vulnerabilities. That's what we were discussing so far, right? Having some third-party dependencies, direct, indirect, a lot of them, and some of them can have like security holes, security issues, right? Something that can be kind of exploited to drop your database, steal your data, whatever. So even though this kind of can contain all the other dependencies, it's here like a separate item on the list because it's that important. So it's definitely something really like dangerous or important these days, to kind of make sure that your libraries are secure. Because if you remember the iceberg thing, you can kind of write only like 10% of your code. The rest, you don't have any control of it. Like it can be secure, it doesn't have to be secure. It usually isn't. And if you don't update your dependencies, if you have like some maybe older versions, there's definitely going to be some issues, some security holes. Right. So the number of vulnerabilities is actually rising every year, so it's getting higher and higher, and the applications are have like more holes which can be exploited by attackers. You can see that pretty much everything except for PHP is working, but then nobody is really using here PHP. So especially like Maven and NPM are kind of worst in this case. Right, so we have some security vulnerabilities, and usually it works in a way that if something is discovered, it's kind of described by some team of maybe like security researchers, and it's published. So like the whole general public kind of knows that there is this security vulnerability, which is kind of good because the good guys can kind of patch it and maybe not use the vulnerable libraries, right? But the bad guys can actually exploit it, and they even have like the whole description what are the vulnerabilities and how to exploit them. For example, this thing, it's like National Vulnerability Database, and you can search for any libraries there and see in which versions are some vulnerabilities, maybe in some later versions where they are fixed, and so on. So for example, if you as a hacker can determine what software is your victim using, like some version of some library maybe, and it's not that hard, you can actually look up what are the vulnerabilities, how you can attack your victim. But it's also useful like for checking whether you have some vulnerabilities on your own. And here you can see some detail of such vulnerabilities. So you can see that it's discovered in some version like 5.0, and then it's fixed maybe in 5.0.16 or something like that. And you have like some detailed description what the vulnerability is actually, and it has some like unique ID and so on. So you mentioned that you know like NPM or Maven, right? And you have this file where you declare your dependencies with their versions. It could be cool if we could somehow cross-check this with this vulnerability database, right? If we could say like, okay, I'm using, I don't know, Angular 6.0. Does it have any vulnerabilities? So to have some tool which can automatically scan your dependency file and cross-check it with the database. Fortunately, there are kind of a lot of these tools on the market. Some of them are commercial, some of them are free. And today I'll be talking about one such tool which is called Snake. You don't necessarily, like the message here is not go and use Snake. You can use pretty much anything which suits your needs. The message is kind of be aware that you probably have some security vulnerabilities in your dependencies, and use some tool which will help you to kind of detect them and fix them. So this tool does exactly what I said, like it can check your dependencies and cross-check it with the database whether there are some issues. It offers like a lot of functionality and a lot of like tools under the hood, but maybe the most basic one is like command line interface, which you can run locally in your project, and it will scan your files and say you have this, and this as a security vulnerability. So that's like normal command line tool, nothing special, but it's sometimes better to have something more visual. So Snake also offers some kind of like web user interface where you can actually like see all your projects, and you can see like all your dependencies here. So here you can see, for example, package.json or Gradle file, Maven file, or Python requirements, and you can see like how many vulnerabilities are there actually. Like this means like high, medium, and low. They are kind of categorized based on the severity. And then you can like click into it and check individual dependencies, and you will see something similar like it was in the dependency database, in the vulnerability database. So let me quickly show you how it looks, the web interface. So you have some page like this, which is like a SNCC homepage.
It's not duplicated, man. You need to drag it out there.
Huh.
Top.
Okay.
Now good.
Alright, so basically this SNCC has like a free plan for open source projects. So if you have something on GitHub, you should be good to go without any like payments. It has some paid plans for enterprise, but for your own projects which are public, you can use it for free. So here I can log in. Huh.
You don't have the Wi-Fi password.
Alright.
Work better. You locus UPC.
Okay.
From capital.
Work better?
Work better. Capital W, capital B.
Sorry for this. Alright, let's see if it works. Alright, so here I have like some dashboard, and you can see something similar like we saw previously. So I can browse my projects here, and I can, well, by the way, just yesterday I added like a Facebook repository for React, if you know React, and it has like 104 high severity vulnerabilities. So you can also, at like public projects, you don't need to necessarily scan on your own, but yeah, I can like dig deeper, and here I can see that, for example,
So it's not even in React though.
here are some like high severity vulnerabilities, and if it was my project, it would actually allow me here to automatically upgrade my dependencies by making changes to my code. This is not my project, but you can see how, like using Facebook React, for example, that even like public projects like this have a lot of vulnerabilities. Let me go back. Yeah. So, for example, if I select some project of my own, like this one, it's kind of slow. Alright, maybe let's skip that part, but I just wanted to show you how easy it is actually to add your project. So, for example, if you just click here, you can, after you link SNCC with GitHub, you can just say, okay, use my GitHub, and it will like list all your repositories which you have under your account. You just click one of them and click add, and that's pretty much it. After you do that, you will see it in this list of projects, and it will be automatically scanned for you in the real time. So even if like 2 weeks later there is something new, it will discover it and update it and send you some email notification. Right. So, are you familiar with continuous integration?
Yes.
Yeah. So basically, like if you have some automated process to check your code after you make some changes, for example, you push some changes to your Git repository, you want to automatically run some checks, like make sure the code compiles, run all the unit tests, right, and maybe some lint or whatever, to make sure you're not introducing any like bad code in your project. And as part of this process, you can introduce also like SNCC scanning. So for example, after I update my dependencies and push them to Git, I can actually like automatically run SNCC and check whether there are no new vulnerabilities as a part of this change. And if there are, I can actually automatically break the build and not allow, for example, like pull requests to be managed or something. But like continuous integration is great and it's necessary, but it's even better to have like some first line of defense to kind of discover those vulnerabilities as early as possible. So as early as possible is actually when you're working with your IDE and editing your dependencies. So if you, for example, bump some version, it's good to immediately see that something can be wrong. So there are some plugins to some of the IDEs which you can use, and even before like pushing your changes to the server, you can discover that there are like vulnerabilities. Yeah, what's also great, it's since the updating of your dependencies isn't so complicated, right? You can just like maybe bump some version to something higher where the vulnerabilities were already fixed, and Snyk can do that actually for you automatically. So it can check like the database and say, okay, you have vulnerability in version 5.1, but this vulnerability is fixed in version 5.2. So it can automatically create like a pull request with this fix and bump the version for you. And if you're okay with that, you just like approve the pull request and manage it. So it's really easy, and it does this automatically for you. So it's really like effortless. What's also great is like if you have some open source project, then there is discovered some vulnerability and it's published into the vulnerability database. And then it's publicly known and it can be exploited. But then usually it takes some time to actually fix the vulnerability and release the new version, and it can take hours, but it's not really likely, but it's more like to be days or weeks, sometimes even months or years. Or maybe the project is not supported anymore, so nobody is maintaining it. So the vulnerability will be there like forever. So Snyk has their own like security research team, which not only like looks for those vulnerabilities actively for new ones which are not known, but if they discover something, they can like provide their own patch even before the official vendor of the library. And this can be automatically applied as part of your npm build. So this kind of really narrows down the window of vulnerability where there is no fix for your vulnerability. So that's pretty great. As far as I know, no other tools offers this. What's also great, like if you're upgrading your dependencies because there is some security fix, it can be hard because maybe the new version has some changes which are not backwards compatible. So it takes time and effort to implement some breaking changes. And it costs a lot of money, right? Because like developers are kind of expensive. And even if there are no breaking changes, when you upgrade some dependencies, there can be like bugs or something. So you need to retest your whole application because there can be some regressions. And it's also like costs a lot of money. So sometimes it can be actually better to keep your dependencies unupdated because the risk is not as big as the money required to update. And that's usually kind of excuse for not upgrading because like maybe we are not even using that part of the library, so let's keep it vulnerable. And what Snyk can do, it can automatically like watch your application at runtime and detect like which part of the library do you actually use at runtime or not. And it knows in which part of the library the vulnerability is. So if you're not using that vulnerable part, it will not like generate the alert for you, because then it might be way cheaper for you to not upgrade and you don't have any like false alarm. So that's pretty useful. Are you familiar with like containers or Docker? Yeah.
Yes.
So basically, I will not explain much about that, but so far we covered only like coded dependencies, like libraries and frameworks. But if you are running your application somewhere, you have some other dependencies which are more like applications. So you're using some SDK for your language, like JDK for Java, for example, some runtime. You are using some database, stuff like that. Something which is like actually installed on the machine. And since in your Docker file there is a list of those like applications which you are using, so they can also like scan them and check the versions and see whether there is something vulnerable or not. So it's not only for code but also like for container scanning, which is pretty good because code scanning for vulnerabilities in frameworks, it's kind of there for quite some time. But in containers, this was nobody ever cared about that so far. So that's useful. And the number of vulnerabilities in those applications are, it's huge, right? Like for Java, for example, you have like new security patch all the time. Cool. There are some resources to check, like for example, Snake blog, or they have their own podcast. So feel free to check that. And if you have certain questions, I'll be happy to answer.
Is GitHub using that internally, by the way? I mean, I have the project on GitHub, and GitHub shows me alerts when like one of the node dependencies has like a vulnerability, and like so it doesn't update it automatically, but like it shows the alert. So I was just thinking that maybe they're actually using something this internally.
Mm-hmm. So for quite some time nobody actually cared about the security vulnerabilities, but maybe in last like 2 years or something, a lot of like ecosystems started to maybe do some solution on their own. So for example, if you are using npm in some later versions, it already says something like you have some vulnerabilities in your dependencies, right? And with some severity is similar what we saw, but it doesn't really allow you much of a management in addition to that. Similar in GitHub, they are using something which is called dependable, I think. It's also quite new, and I'm not sure whether it's out of beta already, but it allows you to also detect some issues with your dependencies, but it's not quite as powerful as like dedicated tools like Snake. But it's great that a lot of ecosystems start to take this more seriously.
What about other type of vulnerabilities? For example, if users sometimes just put some information like password, sometimes hard-coded, or some parts to database, for example, or something like this, which are, when they put it, sometimes for me it was when I just put some token into the GitHub, and can it just find such thing of such type?
So there are like, this is kind of another area, and there are tools which are specialized just on that. I don't like remember any specific names right now, but it's more like about like scanning your tools for security issues. Something like, for example, you can use Sonar to scan your code for like best practices, but this is similar, just for security. And there are also like some like penetration testing tools which can also like test your application at runtime and check whether they can kind of exploit some vulnerabilities there. So there is a lot of security tools for different issues, but for example, what Snake does also on top of what I mentioned is that if you're like in a corporation, it's a big deal with licensing. So each library has its own license, which is different, and there is a lot of them. And if you are using some library, you kind of need to follow the licensing, right? And some license might say, for example, that you cannot use it for profit, or that you need to make your code public or whatever. And Snake offers you to scan all your dependencies for licenses and check whether you are using something which is maybe like a bad type of license, and send you some warnings and notifications based on that.
Yeah, I wonder like how severe all those vulnerabilities are, because like as you show on the slide, for example, React has around, I don't know, 100 or so vulnerabilities. So like, does it mean that everyone can basically hack any website built with React? It probably doesn't. So that's like what I'm wondering. Like,
So
How dangerous is it really, those vulnerabilities?
it depends. Like of course, with like front-end projects and like doing just some stuff in user's browser, right? So you can do something like cross-site scripting or maybe like show some different page or something like that. But if you are talking about backend, those vulnerabilities are usually like more severe. That means like taking control of the database or deleting everything on your machine. So usually in frontend it's not so bad, but on backend it's worse. But not all of the vulnerabilities are like easy to exploit. So as a part of the description in the database, you have also usually like information how hard it is to actually exploit this dependency. But it can be like the impact can be quite severe. So for example, there was this like zip library, like compression library, where you can upload a file and like unzip it on server. But it would allow you to. It has this vulnerability where it would allow you to use those like double dots to kinda escape from the directory where you upload, and you can go anywhere on the machine and do anything. So you can access this password file on Linux, for example, or delete anything on the machine. So usually the worst case is kind of like takeover of the server or the database. But of course, like there was, for example, 100 vulnerabilities in React, but not all of them are like this severe. So is then usually like you need to check like whether it's easy to exploit or it has a big impact or not.
Okay, thank you.
Could I ask?
Yeah, sure.
Yes. Whether exactly this product has some part of open source parts of their code base, or it may be open sourced at all. I mean, Snack product, or it's closed. I mean, code base of this
I'm
product.
not sure whether they are open sourced.
Usually, companies open source some part of their products, and I just
I would assume that it's not open source, and
Mhm.
maybe if it is, then just some parts.
Thank you.
But you can use it for open source project. For
Yes, it's good.
What are alternatives?
What I used at first was like some project from OWASP directly, which is like which was called dependency check. It was like some years ago, and it's not really as powerful as Snake, so it was kind of too much trouble to use. So I didn't use that. I think there is something like Black Duck or
Black
White Duck.
It just
Some
has
duck.
duck in it.
Hopefully, yeah. So I know that my former colleagues were using that duck product, but I don't have like experience with it.
And there's also something called guardrails.
Yeah, and then there is this dependabot, which is on GitHub. Yeah. And there was something called something green. Sorry, I cannot be more helpful, but yeah. Cool. If there are no other questions, then thanks for attention and thanks for coming.